So now that we've introduced ourselves to our reciprocal trig functions, we want to look at differentiating these further trigonometric functions. So the first thing we're going to do is we're going to use the quotient rule to find the derivative of the tangent of x with respect to x. Now, in order to use a quotient rule, we're going to have to use one of our trig identities from National 5, which told us that the tangent of x equaled the sine of x divided by the cosine of x. So we're going to rewrite this as the derivative with respect to x of the sine of x over the cosine of x. Now, to use our quotient rule, we need to identify f. So that's our numerator function, which is the sine of x, and g, which is the denominator function, which is the cosine of x. And therefore we can work out that f prime is the cosine of x, and g prime equals negative the sine of x using our higher derivatives that we learned last year. Now, our quotient rule says that y prime equals f prime g minus g prime f, all divided by g squared. And we're going to substitute in our values. So f prime was the cosine of x, and g was also the cosine of x, and then we're subtracting g prime, which was negative sine of x, and then we're multiplying that by the sine of x. And the entire thing is going to be divided by cos x all squared. Now we're going to collect our like terms together or simplify the top, and so we're going to get cos x all squared plus sine x all squared, and that's still divided by cos x all squared. Now, from that 5 again, we know that the numerator here, cos x squared plus sine x squared equals 1. So I'm going to replace that with 1 over cos x squared. Now I know that 1 over the cosine of x equals the secant of x. So therefore I can rewrite this as my final answer, that y prime equals the secant of x all squared. Now, thankfully at Advanced Higher, these standard derivatives are given to us on the formula sheet. So we've just derived the derivative of tan of x, which was the secant of x all squared. The derivative of the cotangent of x is negative cosecant x all squared. The derivative of the secant of x is secant x multiplied by the tangent of x. And the derivative of cosecant x is negative cosecant x multiplied by the cotangent of x. And we can use our try, then have fun. So the first example, we're going to find h dash x, or the derivative of the function h of x, if h of x equals the cotangent of x cubed. And we're going to use the chain rule to do this. So the chain rule says that we need to let our x cubed be u. So we're going to let u equal x cubed. And that means that y is going to equal the cotangent of u. So we're going to differentiate u with respect to x, and that's going to give us 3x squared. And we're going to differentiate y with respect to u, and the derivative of the cotangent of u is going to be negative cosec u all squared. Then we know that dy by dx equals dy by du multiplied by du by dx, and we're going to substitute in negative cosec u all squared multiplied by 3x squared, and then our final step of working out is to replace that u with the x cubed. So our final answer, the derivative of y with respect to x, is going to be negative 3x squared and then it's the cosecant of x cubed all squared. So if we want to differentiate y equals the secant of 4x, again, we're going to use our chain rule. This time, we're going to let u equal the 4x, and y is going to equal the secant of u. Now, du by dx is going to equal 4, and dy by du is going to give us the secant of u multiplied by the tangent of u. Then dy by dx, or the derivative of y with respect to x, equals the derivative of y with respect to u multiplied by the derivative of u with respect to x, and we're going to substitute in. So the derivative of y with respect to u was the secant of u multiplied by the tangent of u, and then we're multiplying that by 4. Then we need to replace our u with our original function, which was 4x. So the derivative of y with respect to x is going to be 4 multiplied by the secant of 4x multiplied by the tangent of 4x. Now our final example is going to get us using our product rule, and we want to find the derivative of the function of x for tan 2x multiplied by sine 2x all squared. So to use the product rule, we need to identify our f and g. So this time f is going to be tan of 2x, and g is going to be sine of 2x all squared, and I'm going to rewrite that with my sine 2x inside the bracket and my squared outside. Now, using the chain rule, f prime is going to be 2 sec of 2x all squared, and g prime is going to equal 2 multiplied by sine 2x, and then multiplied by 2 cos 2x. Now I'm going to do some simplifying of this, because that gives me 4 sine 2x cos 2x. We'll rewrite that again because it seemed to glitch a bit. From higher that sine x, 2 sine x cos x equaled sine of 2x. And so we can rewrite this as 2 sine 4x, which is going to make life much easier as we simplify once we're putting it into our product rule. So our product rule says that y prime equals f prime g plus g prime f. And f prime is 2 the secant of 2x all squared, and we're multiplying that by g, which is our sine of 2x all squared. And we're going to add that on to g prime, which was 2 sine 4x, and we're going to multiply that by the tan of 2x, which is our f. Now, we want to do some simplifying, and we can realize that since we've got a tan 2x on the right-hand side of our expression, we can derive a tan 2x on the left-hand side of our expression. And so we're going to replace this secant of 2x all squared using the fact that we know that the secant of x equals 1 over the cos of x. So the second of 2x all squared is going to be equivalent to 1 over the cosine of 2x all squared. So if I rewrite that, I'm going to have 2 multiplied by the sine of 2x all squared over the cosine of 2x all squared. And I'm going to add that on to my 2 sine 4x tan 2x. Now the next thing I want to do is I want to replace this sine square 2x all squared over cosine of 2x all squared with a tan of 2x all squared. So I'm going to get 2 times the tangent of 2x all squared, and I'm going to add that on to my 2 sine 4x multiplied by my tan 2x. And now I can take out a common factor of 2 tan 2x. So I'm going to have 2 tan 2x, and I need to multiply that by a tan 2x for the first term inside my bracket, and then I'm going to add that on to a sine 4x for the second term in my bracket. And so f dash x, or the derivative of f of x, equals 2 tan 2x multiplied by tan 2x plus sine 4x.